Hello, and a very warm welcome to this series of papers where we will talk on high performance papers. And today I have with me here Arne Astrup. Very warm welcome to you, Arne.
Thank you so much.
And we will particularly focus on this paper here in the red, which has picked up a lot of citation, but I think also paved the road for a methodology where you can test diets, but also you could say drug candidates, as you already in the highlighted paper here in the green, which also picked up a large number of citation. So that could indeed also be a candidate for a high performance paper. But you were for 30 years head of our department and research here, and have now continued, you could say, your line of research, and I guess also personal interest in the area of preventing and management obesity.
Yeah, that's true. In some way, it's a kind of interesting coincidence that we are coming back to discussing our discovery of GLP-1 being a satiety hormone, that now I'm ending up in the Novo Nordisk Foundation, where I'm spending money on funding research in all kinds of different areas, prevention and you know. So, after the 30 years and doing research in obesity and also being head of the department, I think I still had a strong interest in this area, and the interest was mainly to try to be a fundraiser to enable scientists to do all the studies I felt was really important. And in my role today, where I'm in the management of the foundation, but also is heading a team in a small program area called Obesity and Nutritional Sciences, we really have the opportunity to fund a lot of studies here. And you know, today this foundation have the opportunity to spend about 10 billion Danish crowns every year, and our total fortune have just passed 1,000 billions. So, and of course, it's partly due to the success of the company, the pharmaceutical company, which is of course very successful. So in some way, I think the circle is closed.
Indeed, and you can facilitate good science in many ways. But today we will particularly focus on this paper and the methodology developed here with, you could say, the visual analog scale, which I think that if we have this first slide here with figures, is elegantly explained over to the left with the satiety and hunger scores. You had a lot of measures of satiety and appetite scores here, but these two illustrate, so to say, the principle that you have a scale, and then you score how hungry are you, or how is your satiety level.
Yeah, it's simply a 100 millimeter long line where the extremes are anchored in either are not satiated at all, or I'm extremely satiated. So this is simply, and so you put a cross on the line where you think how you would subjectively, of course, estimate that this is how I feel right now.
Yeah. And then in this one, you show that there's a very high reproducibility when people are coming in 2 times, having the same standard sized breakfast. And a little surprising to me when I read it was that independently on whether you have standardized the diet the day before, you see approximately the same numbers and a high reproducibility.
Yeah, I think the interesting stuff here is that these visual analog scales have been used in many other areas, for example, to record pain, because you cannot measure how much pain a patient have. It's something they can express to you, and instead of they are trying to express it in many words, it started this use of a visual analog scale to try to record it over time and have an idea about how much pain people had. And it was also introduced into this area with appetite, but it was used by scientists without really knowing anything about the precision and accuracy and reproducibility. So that was a reason, because we felt that this could be really useful, but we need to have an idea about if we want to calculate statistical power of a study, you really need to know this variability. So that was really the aim of this study, and we included 55 subjects that came in twice, simply to repeat the same test exactly at two different occasions, highly standardized, and then we could do all the statistics to see how reproducible are these measures.
Yes, and of course that has paved the road, and maybe also since it's picked up so many citations, is that then when people do different types of experimental diets, or as we will show in the next slide, if they test a medical drug to see if it has an effect, then you need to know that that is not just due to random variation and so on. And I also think it's quite elegant that you in the paper, so to see, do the job for people, and you calculate how many subjects should they have in order to be able to detect a significant difference, the power of the study needed, and so on. So
in some way, it's quite simple. If you want to know if beans are more satiating than bread, this is the only way really to test it, to do a study with these measures.
yeah.
And then, of course, you need to know what kind of effect size you are going for, and then do all the statistical power. So you could use it for differences in diet composition with drinks. And of course, you could use it for drug candidates where you have a molecule that has been tested for safety. But before you, of course, the endpoint would always be to see if there's an effect on body weight, if you can use it as, for example, to manage obesity. Then
Of course, if
instead
there's
of
an
having a
alignment.
trial that lasts 3 to 6 months, it's needed really to have something you can do much quicker and have an idea about the effect on energy balance by effects on appetite.
Yeah. And of course, it's nice to see that there's an alignment between the subjective scores, and we as scientists like to see, okay, we also have a hard endpoint that you eat less in the next meal, or you
Exactly.
eat in total.
Exactly.
Yeah. What is the so to say golden standard? Because here you report, so to say, the time course, but then you also in the figure 2 here, that's the mean score of the area under, or the mean score of the subsequent hours. What is people reporting? Do they is it the time course, or do they just report the mean score?
It's typically the mean that is relevant, but and so you can also combine them all into using an algorithm, so you can get an integrated response. But of course, there can be some differences in the time course. That, for example, something would if it's a drink, you would assume that probably a more rapid effect in the beginning, where it's fades away more subsequent. So that's the reason why it's also important to have the time course, so you can see if potentially there's something that is only working in part of this time period we measure.
Yeah, because you could also say that it's the endpoint, because that's where you eat your next meal.
Yeah, exactly.
If you have a lower number there. And maybe that's also illustrated in one of the studies that where you have applied this scale here with the testing of GLP-1 infusion. Actually, this study you applied the methodology. I mean, you probably conducted the studies quite similar in parallel here, but in this one, you gave people a standard breakfast, and then you followed the response here. It's for satiety with saline infusion, and then in black with the GLP. And I guess this is one of the first studies demonstrating that you then can affect your satiety for a longer period afterwards.
Yeah, today, the GLP-1 story is great, and perhaps there will come a Nobel Prize out of it for Jens Holst, who actually discovered GLP-1, and with a focus on GLP-1 as one of the incretins that stimulate insulin secretion when you have a meal. So GLP-1, which is released from the small intestine, I discussed with Jens Holst at that time. We were already collaborating, and we discussed that perhaps some of these peptides coming out from the small intestine could actually be hormones that would inform the brain about satiety after you have eaten, because at that stage we actually didn't know that when you consumed a meal, how could the brain actually know when the guts, the intestines were filled up, and you had sufficient of food and calories and nutrients, and you should stop eating. And if you continue to eat, you'll get nausea, and if you still continue, you'll vomit. How does the brain get this information? And it was at that time it was assumed it was the vagal nerve, but there were also studies suggesting that it could not explain this communication. So it was quite obvious that some of the peptides coming out from the small intestine could actually act as satiety hormone. So I suggested that, and Jens Hans and I, we agreed about that we should try to do such an infusion study where we would simply see if we infused GLP-1, which we had to get synthesized in a private company where we ordered it and cleaned it and sterilized it. And so it was the first infusion in man of the GLP-1 hormone.
Yeah. So
we simply used this methodology, which we had developed a couple of years before, and we were so eager to get this published, so it was published 2 years before the reproducibility study. But when we infused that, it was actually the first study to show that GLP-1 is a satiety hormone in humans, and we actually we made a patent right away and sold it to Novo Nordisk for nothing. And so in some way it's great to see now that such in some way a quite simple study, in some way is will have such an impact. And subsequently there's been many other scientists, including in collaboration with our group at that time, that also made infusions in overweight people and did other measurements to see get a better understanding of the dose-response relationship, etc.
But also, I think also this demonstrates how much of a change, how sensitive is the vast scale. Because when you look at it here, people get the standardized meal. Of course, they are equally standardized before that's before the infusion started or before you have the effect. And then you have a different time course. And then at the end of this, you gave them this ad libitum lunch. And then you could say, okay, the differences in score also translated into differences in energy intake. And you could, just for fun, calculate it up. Okay, if this is then multiplied up to an entire year, 1,000 meals and so on, then it would produce a weight difference of 14 kilos or more and so on. And that matches the subsequent studies that has then been done. But as you also said, this is a way that you can test, because if it doesn't produce any differences, maybe there's no need to run 1 year experiments in people, and in this way you can test it.
Exactly. We had another example. There was another peptide coming out from the gut, GLP-1/2, GLP-2, it's called. We actually tested it the same way, and there was absolutely nothing. And subsequent other studies have shown that it doesn't affect body weight. So I think it fits quite well. And of course, this is a reason why this reproducibility study have got so many citations. It's simply because everybody working with everything from dietary supplements or different in diet compositions or drinks or drug candidates, and probably particular drug candidates, they're using this methodology in the early phase of development simply to have an idea about how much does it affect appetite and energy balance in humans at an early stage, because they need this information to see, of course, if there's nothing in it, it's a matter of concern. But also when it shows an effect, the effect size is actually something that correlates with subsequent weight loss over long term. So it's quite a useful instrument to have to get a kind of early detection of effect size.
And of course, here for GLP-1, there's been a massive number of studies verifying this and seeing, okay, there's an effect. How effective is changes in diet? So let's say that you have, you say, normal diet, and then you change it into a higher protein, more fiber content. Can that be as effective? Because from one point of view, you could say, okay, obesity just keeps increasing. We will also have a talk in this series with Feitel Magos, who has shown in a very elegant small review that the numbers in obesity, the prevalence increases all over the world. So you could say, okay, our diet is not that effective. Is this the drug that's going to change it, or are there candidates for diets which are as effective?
No, I think the problem with, in some way, we know that the obesity epidemic is because people are eating more than they should, but we don't know why they're doing it, because nobody wants to gain weight and become obese. So why are they doing it while they actually don't want to gain weight? And it's a little mystery, because previously we assumed that it was simply because they exercised too little, and also they had a diet that was too unhealthy and gave too little satiety, etc. But I would say it's quite easy to get people to lose 10, 20 or 30 kilos by forced energy restriction over some time. But as soon as you stop this energy restriction, they start to regain again, and typically end up where they started. So the idea was, if we change the diet composition and construct a diet that provides more satiety, and that could typically be a little more protein, more dietary fiber, and perhaps less sugar and refined carbs, etc. And there's definitely an effect on making this change, and that's also something we have shown in both using this methodology, but also in randomized trials lasting for 6 to 12 months. But again, the effect size is typically 2 to 3 kilos. It makes, and you really need to stick to this dietary change because such a change will provide more satiety, so you will automatically or spontaneously consume fewer calories. But 2 to 3 kilos is not much if you have a excess body weight of 20 or 30 kilos. So in some way, it's a little mystery. And I think
But you can
got
say
a
on
better
one side,
idea what are the causes and how to handle this, we definitely need some drugs that can actually help these people, because it's not just a cosmetic problem, it's really producing, as you know, diabetes, cardiovascular disease, cancers, and osteoarthritis, atrial fibrillation, and you name it. There are so many complications and comorbidities to obesity. And of course, it's better to treat the ground condition, the obesity, instead of just treating all the symptoms as blood pressure, cholesterol, and etc. So I think we need both. We need a lot of research that really find out how we can prevent obesity, and then of course there is a need also to treat those who already have developed it and really have a medical need for an effective treatment.
Yeah, but you can also see this illustrates by some extent. I mean, it's generally accepted that it's very complicated. On the other hand, it's quite simple. You only need to produce a quite small effect here,
Yeah,
but you need to do it in each meal. And then you could say, okay, it's shown that then this GLP-1 is one way. But I mean, also from, you could say, a sustainability perspective and doing it without having to medicate the entire population, it would also be nice to find, you could say, an ecological way of doing it naturally, meal, the balance between exercise
exactly.
and energy intake and so on.
It's estimated that within very few years there will be 1 billion people on the planet with obesity.
Yeah.
So we definitely need to understand it more. I think what we are discussing is really also the compliance, both to start to do some more exercise and do it every day as a kind of habit, and the same to change your diet. And I think for those, for example, personally, I have this: if I'm not exercising 3 or 4 times a week, I start to feel uncomfortable, a little depressed, and more pessimistic. So I need, when it's time to go out and get this nice feeling again, and my energy is coming back. But for many people, they have never tried this, and maybe it's really difficult for them, and some will not have the same
No, but
feeling.
I mean, then you're gifted, of course, that you get the good habits and you change.
Yeah,
And but we can just say that, okay, if we look at enough people, the trends are quite clear. It will be interesting to see if there, by some point, GLP-6 into the era, if there will be a change in the prevalence, because I mean, so far it's a global trend, as you say. So
absolutely, and as you know, more and more companies are coming with new GLP-1 agonists, but also where GLP-1 is combined with glucagon and GIP and amylin, other peptides that have an effect on both appetite and energy metabolism. And they have also, some of the new candidates have shown weight loss of 20 kilos over 6 months, better than control, with actually very few side effects, and the side effects are typically a dose phenomenon. So you get nausea and vomiting, and that's really when you get too much GLP-1, too high dose, you start to get nausea, and if you get further too much, you start to vomit. It's exactly the same you see under physiological conditions, that if you eat too much, you get nausea. If you continue to eat, you start to vomit.
And do you know these studies, when they do the initial pilot testing and so on, they still use these VAS scales, of course, electronized, and I guess you can also make a cluster, so you can use, I mean, because we saw that satiety and hunger was inversely related, and you have a different fullness and so on. And I guess you can make an integrated, and you could say appetite score or something like that.
Precisely, yeah.
Is that more sensitive than just taking one number? So you could say, okay, I only ask people for satiety.
I think, sometimes you see that some of them are showing a significant effect, for example, satiety, whereas some of the others are not. And that's quite natural, because they are expressing something slightly different. But if you want to have a kind of one endpoint, you can integrate them into one measure. And many are doing that simply because, having a lot of different measures also increases the risk of an error, that there's just mass significance. So therefore, just to integrate it into one have some advantages.
But could this also be one way of trying? I mean, because as we said, it can be so complicated, your genetics, sleeping, exercise, and what you eat. But could we try to maybe, if we could, I mean, also when we enter the area of machine learning and big data, I mean, if we have sufficiently many, could we start better understanding you could say, why is it that we, as on average, I mean, we are miscalibrated? You could say on average, we need a little bit higher than natural GLP-1 levels in order to so to say, keep the weight balance. Of course, some people are and others are not, but on average, we are, so to say. Could this be a methodology that could be, because I mean, it can be today, I mean, people could do it with a smartphone after a meal, they could score this, so you can collect big data on this.
I think it's a good idea, because we also know that the prevalence of obesity is heavily influenced by your social economic status, for example, your education level. So for those with a long education, there's 3 to 4 times less obesity than those with short or no education. So typically in Denmark, you have a prevalence of obesity among those with long education of about 10%, whereas it's more than 30% among those with short education. So it's really, and we don't understand this completely, because it cannot just be attributed to bad habits. So maybe there's also something with mental stress, social insecurity, that have a kind of biological impact on your brain and disrupt the appetite regulation. Even pollutants as hormone disruptive components in pollution have been suggested to have an influence on the regulatory systems in the brain. So we need to be a little open-minded to understand why we have such a global epidemic.
Yeah, so it has large societal impact, so certainly, and so
definitely, yeah.
But I think that this paper, and also why I indeed invited you to have this talk on this, is it gives at least a framework, and also it had paved the road for doing these experimental trials. And so you could say that the citation clearly showed that it had a large scientific impact, but I also think that the societal impact are indeed obvious, and it could be further utilized, could you say? Because I mean, it's clear that we need the interventions to show the effect, and here it's demonstrated with a drug. But I also, at least since I'm more into the ecological approach, can be used to understand the you could say the dietary interventions in combination probably with exercise and so on.
But it's been a great honor really to be selected for this high performance paper series here. So it was a pleasure to contribute and have this discussion with you.
Yeah, you're very welcome, and hopefully you continue your good work in supporting good science
Likewise.
from your new chair. Good.
Thank you.
Great, Arne.